Okay. All right, so what are vectors? Vectors are little arrow things. To begin our definition here, these little arrow things are called vectors. Vectors are used all the time in higher math. So we're going to learn, this section is just kind of introduction to vectors, like how vectors work, what you do with them. The next section, 4.4, is doing something with vectors called the dot product. And so that's what we're going to wrap up this chapter with, is vectors and stuff with vectors called dot product. So what's a vector? A vector is, it's got a direction and a length, which we call magnitude, how long it is. Vectors can be moved around anywhere. So in other words, these two, this is vector u and vector v on the diagram here. This is u and this is v. Those two vectors are the same, exactly the same, which means their placement doesn't matter. Are you hearing me on that? In other words, it doesn't matter. You could move the vector way over here. It's the same vector. It would be different if it was going down, for example. But it doesn't matter where it sits. It doesn't matter where it's anchored. Is that making sense? All that we care about with a vector is how long it is and what direction it points in, not where it sits, not where it's anchored. Really helpful if you can get that down. I was in the middle of Calc 2 before I got that down. I remember working through Calc 2, you do vectors again, you do them more advanced. So I'd had my intro to vectors and trig and pre-calc and went on to Calc 1, Calc 2, and I was in Calc 2 doing problems with vectors, and they kept moving them around. I'm like, how can they do that? They can't do that. Why are they moving them? And I was totally confused, and I was reading the book, and I wasn't understanding the problems. And then it like hit me that vectors, it doesn't matter where they're at. You can move them anytime you want. You can move it over here. As long as it's still pointing the same way and it's the same length, it's the same vector. So we're going to move them all the time for whatever we need to do. We'll move them around, and that doesn't change the vector. Vector doesn't care where it sits. It just cares how long it is and what direction it points in. Those are the characteristics of vector. Once I got that, I was like, ah! Then everything came together. I still remember that day when I'm like, oh, it doesn't matter where they sit. And then everything made sense all of a sudden, why they were moving them around and why that was okay to do. So I want to be straight with you right up front. Don't miss that like I did when I was first going through vectors. It doesn't matter where they sit. And this author is doing a good job. I like this book. First time I used this book. I like this guy. What's his name? Blitzer. I think he does a good job. It's good. He probably thinks like me, that it's really important that students right away think that he's trying to show you the exact same vector in two different places. That's his intention right off the get-go. When I read it, I'm like, yeah, he thinks like me. It's just easy to forget because you just think it matters. You know, everything else, it matters where they sit, huh? Everything else we do in math, we really care where it's sitting. But not with vectors. We move them around wherever we need them. It doesn't matter where they sit. Okay, so this vector, let's look at vector. Let me make the map a little bigger. Here's the questions. Magnitude of u, magnitude of v, and does u equal v? Yes, it does. So before we answer that, so magnitude of u and v. Okay, so he's going to, what is vector u first off? What is it? Well, it goes from here to here. Again, it doesn't matter where it's sitting. It just matters. Vector u goes 1, 2, 3, 4 places to the right. It's like a slope. It's like a rise and a run kind of thing. 4 to the right, 1, 2, 3, 4 up. The way we call that, now does he get, I wonder if I'm going to jump too far. Let me make sure I don't do lingo that he doesn't bring in. I was going to call that 4i plus 4j. Does he do that right away? How does he call them? What does he say? Maybe I should... Oh, yeah, he does. Good. Yeah, so it's 4i plus 4j. What is the I? I is to the right. Or sideways, I should say. Well, we'll just say right for now. J is up. So we call, it's kind of like 4x plus 4y. I and j become to the right and up. We use I and j for whatever reason in the vector world. So when we say vector u is 4i plus 4j, we're saying it's 4 to the right and it's 4 up. That's what we're saying on that. Jeff?
Particular circumstance?
This particular u vector.
Because it could be left down, right?
Yes, it could in other cases. And that would be negative when we start going the other way. Yeah. So to the right is right or left is I, positive right, negative left. Up or down is J, positive up, negative down. So, because what I technically is the vector 1 unit to the right. That is the I vector. Remember, don't let that throw you off. I put it up there at 8. I put it up here. Who cares? Remember, it doesn't matter where they sit. That's the same I vector. Wherever. It could be over here. That's the same I vector. It's just 1 unit to the right. That's what the I vector is. And the J vector, wherever I want to put it, is 1 unit up. So when we say it's 4 I vectors, which means it's 4 little jumps to the right. And it's 4 J vectors, it's 4 up. That's what vector U is. He's 4 right and 4 up. That's the U vector. Now what's the V vector? Exactly the same thing. Right? From his starting point, 1, 2, 3, 4 to the right, 1, 2, 3, 4 up. He also is 4I, 4J. That's why we say they're the same vector. Because it doesn't matter where they sit. It just matters how far right and up or left and down or whatever they go. Now, how do you find the length? How do you find out how long vector U is, or V? They're the same. Whatever they are, they're the same. What if how would you do that? Yeah, if we know this is 4 to the right and 4 up, and this is clearly a right angle here, right? Because I and J, 90 degrees, straight up. How would you find out how long this other side is? A squared, B squared, C squared, right? Pythagorean, right triangle, right? This is why we're bringing it in trig, because now you know right triangles very well. So the length of the vector, the C, is this side squared plus that side squared, isn't it? Right? A squared plus B squared is C squared. So C is the root of A squared plus B squared, isn't it? If you root both sides of that. Cancel. So C is the square root of A squared plus B squared from the Pythagorean. That's exactly the definition of the magnitude of a vector. The magnitude of the vector is the square root of A squared plus B squared. We're just getting that from the Pythagorean theorem. So those double bars, it's called magnitude. It really means length. Magnitude or length. So double bars around a vector mean the length of that vector, the magnitude. Shanu?
Is that only with the right triangle?
Well, the Pythagorean theorem is only with right triangles, but we can always break any vector into its right movement and its up movement. So this will always work for any vector.
Yeah, because in here they're showing the distance formula. That's right.
Yeah, that is.
Is that because I get in the home over here they're showing to find the distance, whatever the vector. You have to use the distance formula.
You mean on the show me an example?
Yeah.
Let me see. And they do something really. Yeah, no, this is gonna be way easier. Same answer. We'll get the same answer. This is way easier. Yeah. Yeah, because they're all focused on exactly what this point is. What is this point? Over 1, up 5, or whatever. Who cares? That's the whole point, right? It doesn't matter where they are. It doesn't matter. It's funny that they're. Yeah, I don't think the author would be. Because what happens, the way it works, the authors write these books, and then the publishers, what's their names? Pearson. They turn these books into these Math Excel online things. And so I don't think the author, Blitzer, would be very happy with the way, he wouldn't want you to do distance. Well, maybe he does. Who cares? If he does, he's crazy. No, he doesn't. Oh, no, he does. Yeah, that's crazy. I'm not doing that. Well, anyway, that's crazy. Yeah, no, we're just going to use this. This is way easier than the distance formula. It's just a triangle. So let's actually do it. Let's go up here. I got a little bit of room. So maybe I'm wrong. Maybe Blitzer, but I'm not going to do it that way. That's not a good plan. So I'm just going to say, so the magnitude of vector u then is the square root, what is it? Square root of a squared plus b squared? 4 squared plus 4 squared. Square root of 16 plus 16. Square root of 32.
So, but if they don't give you a diagram, then you would have to use...
Yeah, if they just gave you points?
Yeah.
They're not going to do that, are they? We'll look ahead. I don't think so. Anyway, we got to simplify the square root of 32. So how do you simplify the square root? Remember your simplifying roots from your algebra days? Your glorious algebra days? You break it down 4 times 8. And then you just keep breaking that down. 4 is 2 times 2. 8 is 2 times 4. 2, 2. So in the end we have 5 2's when you break down root of 32. Have we done, I can't remember, have we done simplifying square roots before?
Yeah.
So what do? How do you simplify a square root of 5 2's like that? That's what 32 is. 5 2's. Every 2 sends one out. 2 for 1 deal. Have I said that before?
2
I can't remember if I said that in here. 2 2's in, 1 2 out, 2 2's in, another 2 out. They multiply on the outside. 2 times 2 is 4. This other 2 is left inside 4 root 2. That's a simplification of root 32. You aware of that? Square roots are a 2-for-1 deal. Have I said that before? So I teach in algebra all the time, and I'm saying that all the time. I forget what I've said in here and have not. So that's a concept from algebra you're supposed to already know, but I know these things can be rusty. Do you remember that? It's 2 for 1. That's what square roots always do, right? Why is the square root of 9 3? What's in a 9? 2 3. See what it just did? 2 for 1. That's what square roots always do. They always do 2 for 1. It's like shopping at Target. Christmas is here now, right? Halloween's over. Christmas is officially here. It was here before Halloween. You know the stores had. I mean, I don't ever go to the stores hardly, but I heard that they have Christmas stuff already. It's crazy. Anyway. So 2 for 1. If they had a 2 for 1 deal at Target, that's what square roots basically are, is a 2 for 1 deal, right? Have you ever thought about that? 9, you know the square root of 9 is 3. What just happened there? 2 for 1. What's in a 9? 2 3s. What comes out? Only 1 3. So square roots do a 2 for 1 deal, don't they? So when you break down that 16, 2 2's, 1 comes out. 2 2's, 1 comes out. 2 times 2 is 4. The other one has to stay in, 4 root 2. All right, so that's our answer. 4 root 2 is the magnitude. All right, so there we go. So 2i plus j. 2i plus j. So which one of those 4 pictures is 2i plus j? A, B, C, or D?
C.
Yeah, it's C. Does everybody see that? Because this means, you know, I'll start at the origin. 2 to the right and 1 up, doesn't it? 2 to the right and 1 up. 2i, I is sideways, j is up and down. So there it is.
Now, if that was -2, would it be to the left?
Yes, exactly. Yeah, they haven't done any negatives yet. But if it was minus 2i, let's say plus j, then it would be left 2 up 1. It'd be there. And if it was minus 2i minus j, it would be left 2 down 1. It'd be like that. Exactly. And what if they said, hey, is it this picture right over here? It goes right 2 up 1. Is it right here? Could this be it?
Yes.
We would say yes. Because it doesn't matter where the vector sits, which took me forever to get straight. It just matters how far it moves right and up. That's all that matters about vectors. Everything else in math, we care where it sits. That's why it took me so long to get that straight. Vectors, you can move them around. It's the same vector. You know what it is? A vector is like a road sign. That helped me when I started getting, it's like a road sign, right? A road sign says 27 miles that way to Boron, California, or whatever, right? It just tells you a direction and a distance. It's like a road sign. Of course, it would matter where you put a road sign, huh? But anyway, the analogy breaks down. But that's like what a vector is. It tells you a direction and a distance. That's what it is. So which one of those is vector v9 minus 9i minus 8j? A, B, C, or D? B and C looks, it's either B or C, huh? They look very similar.
Very similar.
Yeah, you'd have to blow, I think it's B, but I'd have to blow them up. So which one it goes, what was it, minus 9i minus 8j, is that what it was? We'll go back. Yeah. So which one of those goes back 9? It's this one, isn't it?
Yeah.
Isn't this one going, because this is back 9. This is minus 9, and this is minus 8. They're going by 2s, yeah. It's B. The other one's barely off. It's
Well,
B.
the other one switched.
Yeah, it switched them.
8 down.
Yeah, they went back 8, and they went down 9, didn't they? It's backwards. It's back 9, down 8. Yeah, it's B. Good? Good on that, vectors? So we got the answer. What's the magnitude of vector V now? So V is this. So it's the square root of a squared plus b squared, right? Just like that. Square root of 81 plus 64. It's at 145. And then you break down, what's in a 145? I have no idea. I know it's divisible by 5. So when I look at 145, I just think, I don't know, but I know 5 goes in. So, 5 times 29. 29 doesn't break down. Nothing goes into 29, so we're done. It just stays square root of 145. We can't simplify that. There's not 2 of anything. We can't do 2 for 1. So we're done right there. Remember that? It coming back to you from algebra, how to simplify roots? Is that too quick? That good? Magnitude is just the length, square root of a squared plus b squared. Pythagorean theorem.
I'm waiting for when you say, buy one, get one.
That's what this is. It's a buy one. You to all my colleagues that I ever talk to that do math and science, all of this, math and science is about logical thinking, not memorizing formulas. So what do I mean? So you should look at this, and rather than trying to have perfect memory and all these different formulas, here's what I would do. I would just use a method. I would go, hey, look, this one's back 5, 2, 3, 4, 5, down 8, 1, 2, 3, 4, 5, 6, 7, 8. So it's back 5, down 8. That's that point right there. Back 5, down 8, back 5. That's P1. So that's initial point. It starts at P1 to terminal point. It ends at over 8, 1, 2, 3, 4, 5, 6, 7, 8. Over 8, up 5, 1, 2, 3, 4, 5. Up 5, over 8, up 5. Right there. Now, you could do the distance for me if you really like, but I don't really like. I would think, look, I'm just going to say how far right, how far up for this. Here's the vector, V, or whatever it is. Yeah, vector V. Here's normally vectors you put an arrow above them. That's I guess they're not doing that yet. That's often the way you'll see the notation higher up in math. They'll put V with an arrow above it. That means vector V. You don't have to do that. They're not using that yet. Anyway, I would just look at this thing and go, look, how far right, how far up? From -5 to +8? How far is that? Is that a trick question? 13, right? Because this is 5, and this is 8. And how far up is it? From down 8 to up 5? 13. So I would just do that. Let's go, look, it's over 13, up 13. That's the vector. It's this vector V is 13i plus 13j. That's what it is. So what's the magnitude of V, of vector V? Square root of 13 squared plus 13 squared. Square root of, so I'm just going to keep using my old Pythagorean theorem. 169, what's this, 3, 2, and 18? 3, 3, 8, square root of 3, 3, 8. I don't know if that breaks down. I mean, I know 2 goes in. That's about all I know. Oops. 169. Oh, yeah, which is 13 times 13, because I just got that. So what's the answer? 13 root 2. Right, because the 2 13's in, sends 1 13 out, the 2's left inside. 13 root 2, they didn't want the magnitude. So they just want this. 13i plus 13j. Does that make sense? How I did that, was that too quick? On that? Right? I just subtracted these numbers. If you want more of a formula, I did 8 minus -5. 8 minus -5, which is 8 plus 5, which is 13. But really, it's better if you just think 5 this way, 8 that way, it's 13. Right? And same thing for the other one. It's 13. It's always better to do math and science by feelings. Does that sound funny for the math teacher to say? I want to get you in touch with your math feelings. It's true. You can't memorize all the formulas in math science. You cannot do it. You've got to start to feel it. You've got to strive more and more to just see it and feel it from the picture and go, it's that, it's 13, you know. Trying to do all math by memorized formulas, it just gets too tedious and boring and hard and terrible. And anyway, you get the deal. It's always better to do these kind of pictures, and seeing things is always better. There's nothing magical here. So we got vector U is 9i minus 2j. Vector V is minus 10i plus 5j. And they want us to add the two vectors. How do you add the two vectors? Just like you would think. The I stuff with the I stuff, the j stuff with the j stuff. Just like terms. I'm just going to line them up vertically. Minus 10i plus 5j, there's v. Add them up. U plus v. U plus v is, what's that? Negative 1i plus 3j. It's a 5 here. There we go. They don't even want the magnitude. They just want the summation vector, the u plus v vector. So just add the I stuff and add the j stuff. Pretty natural? All good? That's all they want on that problem. Add the two vectors. That okay? I'll move on. Okay, so now we got vector v. They want v minus u. So vector v is minus 4i plus ha minus vector u, which is 7i minus 6. So u, or v, this is vector v here, minus vector u. Yeah. So now, why did I put parentheses? So you could put parentheses around everything if you want. So it's vector v minus vector u. You know what a minus sign does in front of parentheses, huh? It distributes to both of them. So go ahead and go boom, boom. Can you distribute those? Give you a second to finish that. Distribute those and just combine like terms. Give you a second there. So the first parenthesis, there's nothing in front of the first parenthesis, so it's just minus 4i plus 8j minus 7i plus 6j. Good. And then minus 4i minus 7i is minus 11i, and 8j and 6j, 14j. Good. Just like terms, vectors. Let me break that out for you. So they're saying that we've got vector v. Well, yeah, it's right there. I don't need to rewrite it. So they're wanting me to take minus 5 times vector v. That's called a scalar. I guess you don't really need to know. Scalar just means like a normal number. No, it's not a vector. It's just a number. We call that a scalar. I don't know why. It just means not a vector. It means a number. In the vector world, they call that a scalar. It's not a number. It's not a vector. It's just a number. It multiplies. It just multiplies those two. So 45i plus 30j, just normal multiplication, nothing fancy. You don't have to know the name scalar. So there we go. Just multiply them. Nothing fancy there. Good. That's a vector minus 5 times as long as the original vector v. Same direction. Okay, there we go. So they give me u and w, vector u, vector w, and they want the magnitude of w minus u. So they want remember the double bars mean magnitude, length of w minus u. So they want so first off, I got to get w minus u. So minus I minus 4j, that's w, minus u, what is u? 2i minus 8j. Okay. So let's do that. So it's minus I minus 4j minus 2i plus 8j. Everybody good so far? I just distributed like that. How we doing? And then minus I minus 2i is minus 3i. Minus 4j plus 8j is plus 4j. Everybody good to there? And now how do you do magnitude? Square root of a squared plus b squared. Right? Magnitude of any vector is square root of a squared plus b squared. Pythagorean, length of, right? It's the length of the vector. That's Pythagorean theorem. So it's going to be negative 3 squared plus 4 squared. Any idea what that'll come out to be? Yeah, 3, 4, 5 triangle. That's a 3, 4, 5. Right? Let's get square root of 9 plus 16. Square root of 25, 5. So that's the length of the magnitude of w minus u. This is the w minus u vector, and the length of that vector is 5. Easy? It's your favorite section so far, maybe. It's always nice to begin something new because they start out kind of basic, huh? Before they start going crazy with it. All right, so we have vector v here, minus 24I minus 7j. And they want the unit vector. What is a unit vector? Let me write it up here. Unit vector equals length 1. That's what it means by unit. Unit means 1. So they mean, hey, take that vector and shrink it down to only be 1 length, but keep it in the same direction. We do this a lot with vectors in higher math. All the time. We'll take a vector and turn it into its own unit vector, which means shrink it down to be a length of 1, but keep the same direction. So how do you do that? How do you take that vector, or any vector, and shrink it down, yet keep the same direction? Well, what you do is you divide by its magnitude. Because however long it is, if you divide by that length, then its length is only 1. Does that make sense? So the unit vector for any vector v is v divided by the magnitude of v. Does that make sense? Remember, magnitude of v is just a number. That's what you got to get straight as you go into higher. If you go into higher math and you do a lot with vectors, you always got to keep straight. Is this thing a vector or is this thing a number I'm looking at? What is this thing? How's that going to work out? So in other words, I've got to take vector v minus 24I minus 7j and divide by the magnitude. So I'm going to divide by its own length to make its length 1. So what is its own length? Well, it's Pythagorean theorem. Square root of 24 squared plus negative 7 squared, huh? So if you divide a vector by its own length, you're going to make it into a length of only 1. And that's what you're going to do. So what is that denominator? It is the square root. Is that 576? I think I remember that one. And 49. Is that 625? Oh, and that's just 25. Nice. Square root of 625 is just 25. So, my final answer, bring it up here, final answer then is minus 24, just put that 25 in each one separately, I minus 7 25ths j. There we go. That is of length 1, and it's the same direction as the original vector. You see what happened there? Is that okay? So that vector, that new one, is of length 1. So unit vector, length 1 vector, headed in the same direction as the original vector. Now it only says 1 mile to Boron, California, but it points in the correct direction. Is that good? Everybody okay with that calculation? Just divide by the magnitude. Numbers came out nice. Okay, so they're giving me a vector v, and they're saying, hey, the magnitude, the length of vector v is 28. And the angle, the heading of vector v is 135 degrees. Turn that into like an IJ statement, is what they're saying. So let's think about how we might do that. So I'm going to draw an axis system. I'm going to make an angle that is 135 degrees. So where's an angle that's 135 degrees? Which quadrant's it in? 2, right? Because this, as you know, is 0 degrees, and straight up this would be 90, and this would be 180. So 135 is right there, isn't it? So the vector is headed in this direction, 135 degrees. That's what it's saying. At a heading of 135 degrees. And how long? How long is it? It's 28 long. So there's the vector. Here's the vector we're talking about. This is vector V. So vector V is 28 units long, headed in the 135 degree direction. Turn that into an IJ statement. That's what they want me to do. Turn that into an IJ statement. So let's think. Let me derive it with you. I could just write down the formula and go, here you go, boom, boom, boom. Let's think about what the formula is. How would I actually figure out where that is? I could bring down and make a right. I'm starting to do it. I made a right triangle out of it. And I want to figure out how far. Call this X, call this Y. If I could figure out X and Y, that's my I and my J, isn't it? That's how far over and up the vector really is. So how do you find those?
Using unit circles.
Yes. Yeah, unit circle, and then we'll multiply by 28, because it's not actually unit, it's 28 units. But yeah, we'll use the unit circle and multiply the answers by 20, because unit circle means 1. Right? Unit means 1. So yeah, so Wendy's right on the money. We're going to use the unit circle, but then take the answer and go times 28. The unit circle will give us the direction, and then the 28. So you tell me, what if I was to say, guys, I really want to know what's the X and Y coordinate of this point right here? Because that's my deal, right? X, Y. That'll tell me my X, Y. It's basically a coordinate, isn't it? I want to know the X, Y coordinate of that dot. And let's just say this is 1. Like Wendy's saying, let's just so it's 1 for a minute. Now I'll just take whatever answer I get and go times 28. So if it was a 1, if I said, hey, I've got a triangle, the length of the hypotenuse is 1, which means what? Which means you hit the unit circle, right? Radius 1, circle, unit circle. At the edge there, if you make that 1, I'll just take the answer times 28 once I'm done. So what is the X, Y coordinate of that point at the angle 135 degrees, at the opening 135 degrees? What is the X, Y point here? Right. Yeah, and how do you know it? What is X always? Cosine of the angle. What's Y always? Sine of the angle, right? We have learned that like crazy deep, right? X is cosine, Y is sine. Well, there you go. That's exactly what you do to turn any angle for a vector into the IJ thing. You just say, well, for any vector V, it's always going to be cosine of the angle times I plus sine of the angle times J, except for, what are we missing? That would make it length 1, and so we've got to throw in the magnitude. So you put magnitude of V, its length in the front. There's the formula. See how they came up with that? Because we know X is cosine of the angle, Y is sine of the angle on the unit circle, and then just multiply through by the magnitude, the length of the vector. And you've got it. See, all this vector stuff flows right from all that we've studied about triangle science, trigonometry. So that's all you got to do. So then let me do that with you. So, oops. Okay, so let's do that. So vector V will be 28 cosine of 135 plus 28 sine 135. You with me? You just put cosine of that angle. Oh, I forgot the I and the J, didn't I? And stick in an I right here and a J right there. It's just going to be whatever the length times the cosine of the angle I, the length times the sine of the angle J. And so, yeah, so we know that one, huh? That's, now do they want radicals or what do they want? Oh yeah, exact radical answers. Yeah, so that's right. So cosine of 135 That is negative root 2 over 2. You can use your unit circle on the test. You know, you'll have your unit circle on your 3x5 card. You should always have that unit circle on that 3x5 card. So that'll be I plus 28. Sine of 135 is positive root 2 over 2. J, like Chanu was saying, he's right. Good so far? I can't just use my calculator and get a decimal. Why? Because they say use radicals. Give an exact answer, no rounded decimals. So I have to use the unit circle chart and get the root 2 over 2 off the unit circle. But you guys are pros at that, no problem. What do you do here to simplify? 28 over 1, 2 goes into 28. 14 times just cross multiply. Negative 14 root 2i. Same thing, plus 14 root 2j. We're done.
Would there ever be an instance of imaginary numbers in this? Different eyes.
No, yeah, that I is not this I. Yeah, we're using I for a totally different purpose here. Yeah, it's not imaginary. Although all of math is imaginary, really. Anyway, I won't get too philosophical. All right, it's made up to describe real things. You know my whole spiel. All right, so anyway, so there we go. Is that good? Does that make sense how I did that? You okay with that last simplification? All right, let's try this one here. Okay, we'll do that one. Try 5u minus 4v. Well, I don't want to do that one. That one's bugging me. Let's just start this one. I'll point to a couple things and we'll stop. So this is a work backwards one. So they're telling me vector v is minus 7i plus 15j. And they want me to find the magnitude and the direction. Can you find the magnitude first off? You can find the magnitude, right? So what's the magnitude of vector v? Is that right? Square root of a squared plus b squared? Like that. Square root of 49 plus 225, which is the square root of something, 274. Does that simplify, root 274? Hey, hold on, guys. I mean, it is a little bit distracting, and I'm officially on time, right? We've got 1 minute left. I'd appreciate it in the future if you didn't distract everybody by leaving beforehand. Thank you. All right, 30 seconds. Let's finish it up. 274 divided by 2. 2 times 137. 137 doesn't break down. We can stop right there. And yeah, because that doesn't, I don't think 137 breaks down. I'm sure it doesn't. It's an ugly number. So root of 274. And there we go. That's the magnitude. We'll have to get the direction angle next time.